Welcome viewers to Gateway Learning Center YouTube platform. Today we're looking at chemistry under organic chemistry. So under organic chemistry, we have dealt with alkanes, we've dealt with the family of alkenes, the families of carboxylic acids, alcohol, the formation of esters. So today we'll focus on petrochemicals. Then after petrochemicals, we shall also touch on polymers. That will be the end of organic chemistry. Now, whenever we're dealing with petrochemicals, we're dealing with what we call the fossil fuels. So these fossil fuels is the major part under petrochemicals. Now, we need to understand that we have about three major fossil fuels. We have three major fossil fuels which we normally look at. So the first one, we'll talk about coal. The first one, we have coal. Then apart from coal, we have what we call crude oil. We have what you call the crude oil. Then from crude oil, we have now what you call the natural gases. Okay, so these are the major part of the fossil fuels we're going to discuss on today. So from crude oil, maybe the common name we can talk about what we call petroleum. Yes. Now, the background about the crude oil, the fossil fuels, we need to understand that these are natural resources which we have. When we say they are natural resources, it means that these things are non-renewable resources. Now, non-renewable resources are resources that cannot be replaced once they are finished. So, crude oil and other natural resources, they came as a result of the dead marine creatures, which was sink under the seabed. Now, due to three factors, the pressure, temperature, and bacteria, these are the ones that formed crude oil after million years has passed. Then the crude oil started to be squeezed out of pressure into the porous rocks. Then it was started being discovered. So it is a natural gas which we are dealing with today. We'll look now at petrochemicals from the aspect of crude oil or the petroleum. Now, under petroleum, we'll talk about the fractional distillation, the fractional distillation column. So the fractional distillation column is a column which is used to separate different types of fractions within the crude oil. Now, in a crude oil, remember that a crude oil, these are what you call crude oil. We are saying, let me see, just write the word here. So we are saying crude oil they are hydrocarbons. So they contain mainly of hydrocarbons. Remember, hydrocarbons, these are compounds that contains hydrogen and carbons only. So for us to have the different fractions in these hydrocarbons, each part of hydrocarbon is now called a fraction. So in crude oil, we have, for example, we have petrol, we have kerosene, we have naphtha, we have LPG, liquid petroleum gas. So that petrol from the crude oil is called a fraction. So we'll look at now the diagram which is used to refine crude oil. Okay, so this is the diagram which we are referring to it as the fractional distillation, the fractional distillation column. Okay, so this is the fractional distillation column, which is used to separate different fraction inside the crude oil. So what we are saying now is that if we have crude oil here, this crude oil, it's a mixture. Crude oil is a mixture of hydrocarbons. Now, because crude oil is a mixture of hydrocarbons, you find that each part of a mixture, so each compound is called a fraction. So each compound is called a fraction. Then this fraction has different physical properties as well as chemical properties. So this means that the properties of the first fraction within the crude oil will differ from the properties of the second fraction within the same crude oil, meaning that the number of carbons in each fraction will differ. So because the number of carbons in each fraction is different, you're going to discover that one, the melting point and the boiling point will differ. So that's the physical part. Then in terms of reaction, one part can react fast than the other, or we say the other one is flammable than the other one. As a result, the chemical aspect is also different. Now, in this fractional distillation tower we are looking at, we are going to find that just create space. Okay, so what we are saying now is that in this fractional distillation tower, on the first part, or let me start with this part, we are going to put the LPG. So liquid, this is a liquid petroleum gas. So this one is highly flammable, and its chemical properties and the physical properties will differ from the one which will be found here. Now here we are going to find that we have what you call the gasoline. The gasoline, or the other name for gasoline, is what you call petrol. So the properties of the liquid petroleum gas and petrol will differ physically and chemically. Then from here, we are going to have another compound which is called the naphtha. So apart from the naphtha, we also have what you call now on number 3, we have the kerosene. Then from kerosene, on number 4, we are going to get what you call now the diesel. Then from diesel, we also have what you call the fuel oils or wax. Then from here, we are going to get what you call lubricating oil, or talk about wax. Then the last one, we can talk about the tar. The other name for tar is called the bitumen. So these are some of the compounds which are found within the fractional, which are being refined under the fractional distillation column by the process called fractional distillation. Remember, each compound have what you call the different boiling points. So because they have different boiling points, they are going to be refined or extracted at different levels. So for example, this naphtha, which is being extracted here, when crude oil is injected here, here are going to find crude oil. So when crude oil is put here, then of course there will be a source of heat from there. So this crude oil will come here, then the temperature will be increasing depending on the amount of temperature which can be supplied to this fraction distillation column, and then at how fast or the rate they want the fractions to be extracted. So we'll find that here you're going to have the highest temperature. Temperature increases as you go, temperature decreases as you go up the column. So here you're going to have high temperature, then you're going to have low temperature. So if crude oil is injected here where there's high temperature, remember these are some of the compounds which are found within the crude oil. Then from here, the same crude oil now, here there is high temperature on the bottom. So the heat now will be eating up this crude oil. Those compounds with low temperature or with low boiling point or melting point will first evaporate and condense into these cups. After they condense here, they're going to be extracted out. So the lower the melting point, the faster that compound will be removed from the fractional distillation column. And the higher the melting point, the slower it will be extracted out, because those with high melting point, they are lighter compound. Okay, so the lighter the compound is, the faster it will be removed from this column. Then the heavier it is, the slower it will be removed from this fractional distillation column. So basically, this is what happens under fractional distillation when oil is being refined. Okay, so from here now we can move on to the functions of each of the compound which we have discussed here. So for example, the first one, the liquid or liquefied petroleum gas, which is produced here, liquefied petroleum gas, is the one which is used for cooking. It is used for cooking. Now, when we say it is used for cooking, we are saying that those people who use gas stoves, they depend on this liquefied petroleum gas. It is highly flammable. When we talk about the petrol or gasoline, of course we know and we understand how petrol is used. This is a common compound which we normally know or hear that when the prices of fuel goes up, we know that petrol is one of the compound which is being affected. Okay, so petrol, it is used, of course, in vehicles. Then whenever we talk about the naphtha, we are talking about it is used to make plastics. Naphtha is used to make plastics and other solvents. Then we come to kerosene. So kerosene, which is commonly known as paraffin. Kerosene, which is also known as paraffin, it is used in jets fuel. It is used in jet fuel. Then apart from kerosene, we discussed on diesel. So diesel is also a common compound which we know. So diesel is also used in vehicles. Then apart from that one, we talked about lubricating oil. Now, lubricating oil, talking about petrochemicals to lubricate, talking about making something slippery. So lubricating oil is used to make, for example, grease, the one which reduces friction. Then of course we have wax can be used to make candles. At the same time can be used to make wax, talking about candles. Apart from candles, polish. And apart from polish, can also be used to make grease. Then the last one, which we discussed on, was the one which comes out here, the last one, which is bitumen. Bitumen is also referred to as tar. This one is used during road construction on the surface of the road. Apart from this, it is used in roofing. So these are some of the functions under crude oil and the types of compounds which are being produced. This is called the fractional distillation column. Now, there's another aspect apart from this. We need to understand that these light compounds are so demandful. When the demand is high for light compound, e.g., I'm talking about petrol or liquid petroleum gas or diesel. When the demand is high for these, now what happens is that for the companies that provide these substances, they will make sure that they're going to use those compounds which are not demand. For example, they can use a compound that contains wax. So this compound which contains wax, it has more carbons. It is a heavy compound. So they're going to break down this wax into smaller compounds in order to supply the demand which is needed. So what will happen is that wax will be broken down into, so wax being broken into smaller compounds, e.g. petrol, liquid petroleum gas or diesel. Now for them to do this, they're going to use what we call now different types of breaking them into different compounds. At this point now, we'll talk about what we call the catalytic cracking. So for them to be broken down, they can either break them by using catalytic cracking, or they can use thermal cracking. Now at this point, these two will be the type of cracking which you can be of course help the process. So when talking about the cracking, we are saying cracking is a process of breaking down the larger molecules into smaller ones, either by using a catalyst or it. So when they use a catalyst, that type of cracking will be now called catalytic cracking. When they use it to break large molecules, it would be now called the thermal cracking. So these are two types of cracking which can help to break wax, or apart from wax, they can use also kerosene, paraffin can be broken down into smaller units in order to make petrol or diesel. So these are two types of cracking which can be used. Of course, apart from these types of cracking, we have hydrocracking. We also have other type of cracking apart from hydrocracking, apart from thermocracking and catalytic cracking. But under crude oil, normally they focus on these two types of cracking, thermal and catalytic cracking. So this is about how crude oil are being decomposed into different types of compounds in order to meet the demand of day-to-day lives. So remember, we said crude oil, or under petrochemicals, we talk about the fossil fuels. So fossil fuels, the major ones we talked about the natural gas, the crude oil, the major one, and the coal. Then we said these crude oils are natural resources which can be finished, meaning they are non-renewable. Once they are done, they cannot be formed on the same place. We need to go and find somewhere where they can be discovered. So thank you for watching.